Okay, since now works, I guess.
Okay, that's great.
Yeah, okay.
Uh, just we need to show the note well, and then we're going to start.
Yep.
We'll just run it the same way we did before. Okay, welcome back to the second and final tea session in Vienna, our hybrid meeting. I'm Lou Berger. We have my co-chair, Pavan Biram, online, as well as our secretary, Luis Contreras, in the room. This is the same note well that we showed before, and I think everyone is familiar with it. And with that, I'm going to yield the floor to Gaetano.
Hello. Hi, everybody. I'm Italo Busi. I'm presenting on behalf of Code. Can you hear me?
Yes, you sound good.
Yeah.
Okay. Okay. I'm presenting on behalf of co-authors proposed updates to the common T types. So what is the objective of this document is to add, to do some minor tiny update to the existing ITF-T type YAM modules, which is published in RFC 8776. This update is very small and backward compatible with what has been already defined. The fact that we need to add a new type def and a new grouping with two leaves. And we had some process issues to discuss, which discussed on Tuesday, yesterday with the NetMod working group, because we are a little bit afraid there is some reluctance on the BIS approach. Reason is the document is quite long and we just need to do a few changes, very minor changes. And that we in the A776 we have other YAM modules which do not need to be updated. And what we want to put into this draft is very simple, is a little things which is very mature because it's just moving things which are already defined in other working group documents, some of which are actually now in the working group last call. So we need to have a way to be fast on progressing this document if we want to make these entities available to a broader applicability and without blocking the progress of the documents which are already mature. So what do we need? The technical content is basically a new type def, which is called bandwidth scientific notation to represent the bandwidth of a packet link, but also of a packet LSP in a way that is readable, not like a floating 32, but is a scientific notation numbers. This is already defined in the draft ITF-T's Young L3T topo. However, the proposal is to move it in the T types because this type def have a broader applicability. It's not only limited to packet T topology, can be used, for example, by LSP or tunnels, and it's also not limited to packet technology. We have recently seen some cases of non-packet technology that may need to express the bandwidth in as a number in bit per second, and they could benefit from this type def. And then we have a new grouping, which is called encoding and switching type, which contains the two leaves for the encoding and the switching type. This grouping was initially defined in the pack computation draft by copying from the T YAM model, ITF-T YAM model, trying to keep alignment between the two models. However, we discovered that quickly we went out of sync. So we agreed to move this grouping in the ITF YAM TE, import it in the pack computation, then we guarantee the alignment between the two models. But again, this grouping may have a bigger applicability than just T tunnel and pack computation. So moving it to T types will make it available to a broader applications and make sure that everybody has a common approach to configure encoding and switching type in Yang. So we need just this one, which is quite a tiny update. The process that we propose is therefore not to go with an RFC 8776 bis, but to have this document updating the RFC 8776 with a new version of the T types only. So the T type packet types in the RFC 8776 will remain unchanged and will still be valid because A776 is not obsoleted. And since the changes are quite small, we we can expect to have a fast standardization to make not to delay the work on layer 3 to layer topology on ITFT and ITFT pack computation. The last two are the T is already in working group last call. T pack computation is ready for working group last call. So we will not need to delay too much if by moving the common part on this draft. We discussed the approach from the process point of view, and Edmond gave the feedback that updating the RSC is a viable option. However, the suggestion we got is not to put the diff into the main body, but to put the whole YAM model into the main body, and maybe to mark with some comments to the RFC editor what has been changed with respect to the latest to the RSC. We plan to update the document according to the suggestion from Edmond. And then about the next steps, the first point was to get feedbacks from working group and ADs on the process, and that we got yesterday. Then we have feedbacks from this group, from the Ts on the technical comment. So even if these type different grouping are coming from mature working group documents, please review and give us any comment and feedbacks. And if the proposed approach is accepted, we think the document is ready for working group adoption, hopefully soon. We will keep updating the draft based on the comments from the working group, and we can align the working group's ideas that depends on this document according to the decision to move forward on this direction. And it will be great if you can go in last call together with the first abandoned working group ID, not to give too much delay on the process. And that's all about the content of this draft. Thank you. Thank you. Any comment or question?
Hi, this is Blue Burger. So I was in NetMod, which I co-chair, and I heard the comment to you a little differently than you heard.
Oh, okay, sorry.
What I heard is that there are two options really available. Either do Abyss and change the whole module, excuse me. And it's in particular, do not do any new tooling. New tooling is a bad idea. And so that's option one. Option two is do a document that contains only the change and as an update to the existing document. So no BIS, just an update. And that was proposed because the way you presented it is that of the modules that are in the base document, you're only updating one, not the others. And so the update approach seemed to be a better match. So that's what I heard.
So here the update, yeah. So we plan to continue with the update, and then we don't put the diff in the main body, but the whole YAM model, if I understood correctly.
Just the one module, not all the
different... one module, yes, one module, yes, yeah. Not all, yeah, not the two.
Okay, great. Thank you. Maybe I misheard you this time, and it wasn't you who misheard, but me who misheard. All right, thank you.
Thank you.
Let's move to the next presentation.
Okay.
Hello, can you hear me, Pavan or Lou?
Yes.
Okay, great. So this is Tarek, and I'm going to give you a quick update on this document. It's a solution document for realizing network slices in packet networks. I'm giving this update on behalf of the co-authors. Today, I will not dig deep into the solution. We presented that earlier. I will give a current status of where the document stands, and then talk about the next steps that we have. If you can, should I click for forwarding, or maybe someone can go forward to the next slide, please?
You have it at the bottom of your screen. Just under the slides, it should have.
I see it. Thank you, Lou. Thanks.
Sure.
Okay, so here's the status of the document. Revision 08 was pulled for working group adoption. We have received detailed review, comments, and review as well from the working group members, multiple working group members, and there were some clarification questions raised on the email list. Notably, would like to thank Adrian for his thorough review as well as his review comments. Med, Bo, Kenichi, Zibu, and Dhruv. There were some comments that we tried to address on the list, and there are still some comments open, and we're planning to address them, document them in the next revision, and we'll talk about the plan to progress further. There were some comments that were pointed out as of immediate concern. So those are the ones that we will look into addressing in the next revision, and then possibly document the other ones in a section. Okay, let me move on to the next slide where we talk about the next steps. Based on the adoption poll results and the working group chair's feedback, the plan is for the authors to issue a new revision, which is 09, going to be 09. This will address the comments that were of immediate concern. Some of them are related to references of individual solutions that are driven in other working groups. So those we will leave them out of this document for now, and maybe the solutions will be referencing this solution document. We will add a new section to track all open issues that were raised on the email during the working group adoption. So these issues will need to be addressed before working group last call. We will change the status of the document to informational. We got this feedback from the poll, and for now, we'll go with the working group consensus on that, and depending on how the document progresses, we will revisit. Once the revision 09 is published, we will notify the working group of its existence and ask them or solicit for further feedback. If there are no concerns raised, the guidance is to republish from the working group chair is to republish the document as a 00 working group document. The plan now is to push this revision 09 maybe by the end of this week or early next week. These are the milestones that we have set. I don't have much further to talk about this, but I'm happy to answer any question that anyone in the working group might have. It was a quick update. Sorry, maybe not too much exciting, but I'm happy to talk about many other things as well. Thank you.
Shifang, please go ahead. You should also.
Yeah, you can hear me, right?
Yes, and you should be able to change your slides by clicking on right underneath the slides.
Okay. Yeah, this presentation is a quick update to this document, which is a service delivery model for the network slicing. So the current data model with the existing document, we could support certain types of communication types. We could do P2P and A2A, any to any. With this update, we'll support the P2MP and MP2P and MP2MP, the other type of the communications. So this is a simple Yang. Oh, wait a minute. Yeah, this is a simple Yang augmentations. So we add two Yang modeling constructs. One is called replication groups. Another one is called receiver constraint group. So that to handle the P2MP and MP2P. So this is the description about how do we do this. The idea is that we group several connectivity constructs together. And once we group them together for the replication group, any traffic to send to one of this group will be replicated to other construct. This way we'll easily make the P2P construct into a P2MP. So in a similar way, if we group them several P2P constructs into a receiver constraint group, then we know on the receiver side we have constraint. So we need to have the constraint applied to all those constructs to achieve MP2P. Some examples here. So I don't need to, this is P2P, so it's already there. We just list from the from side to the to side. So that's nothing new. Here, this is the idea for the P2MP. So we already have two constructs, ID1 and ID2. And here we're trying to do from NIC5 to both, I think it's typo, the 9 and the 10. Then we have the two IDs, 1 and 2, we group them together. So we have this entry list, 1 and 2. Then we achieve the replication, and then it's a P2MP. So similarly, for the MP2P, here we have two constructs, 1 and 3, and we put them into a group. So we know at the receiver side, we have certain constraints. So with those two simple modeling augmentations, we can achieve all types of communications. Then the 8-way is already supported. We don't need to mention here. So with this way, then we'll be able to handle every types required by the network slicing document. This augmentation is only for this model for now, but we propose this as a generic method which can be applied to other models if the working group agrees to do that. That's about it. And this document, other things will be ready for the adoption. Okay, so I see some people lying on the queue. So should we go ahead for the questions?
So before we open up the queue, a very high level question.
Okay.
So we do have a service data model that the working group adopted, and I believe you are proposing another service model that I believe you are saying it can complement the other. So can you talk about the relationship between the two models, and then we can open up questions?
Yeah, I believe the next presentation from Louis will further clarify the relationships. Here, this model we can use that in two ways. Either it can be used as a service delivery model, which means once we got a service model, we translate it into as a service delivery and map to the network topologies. If we wish, if user wish to use this model as a service model, then this model will support the topology-aware service. So you can have some middle abstract node specified by the user. So that's a complement.
Okay, let's start with the questions. Greg?
Hi, Greg.
So if I understand correctly, all these types of communication, do you you consider them to be unidirectional or bidirectional?
That's right, unidirectional.
Unidirectional. So do you see any benefit of having point-to-point bidirectional?
Yeah, for the point-to-point bidirectional, we need to have two entries, one to the one direction and the other to the backward direction. This is a, yeah.
Yeah, okay, I don't want to use this not really popular MPLS-TP story, but there are some differences in when we request bidirectional service, and at that time it was like co-routed or associated, so where they're traversing the same nodes and links is not required. So what I want to say is that there are different flavors and different types of bidirectional point-to-point construct. So just combining two might not be sufficiently expressive.
If you feel proper, we can add some further descriptions, further leaves to specify we need co-routed or not co-routed.
Okay, let's think about it and talk about it on the list. Thank you.
Yeah.
Tarek?
Hi, Tarek.
Thank you, Shufeng, for the great presentation. If you go back a couple of slides where you presented the types of connectivity constructs, you had multi-point to multi-point, for example.
Multi-point to multi-point, yeah.
Right. Right. And would you agree that I could model this with a set of point to multi-point connectivity constructs? That's question one, and I have another one, if you don't mind.
So you mean you just say everything connect to everything without the new addition?
Yeah, so this is basically n
That's
times
any to any, right? So
no.
I will try. Okay.
It's a bunch of point to multi-point. So we will give you multi-point to multi-point. And maybe we can take it offline. That's fine.
Yeah.
Okay.
Yeah.
So
we
the
can
next
discuss
question,
further details. Okay.
Okay. The next question I have is the network slice framework draft only talks about service demarcation points, SDPs, and they used to be called NSEs. They don't have a notion of any other nodes or endpoints, like the abstract node that we talked about a minute ago. You could have nodes that are not endpoints in your topology. Are we asking the slice framework draft to mention or talk a little bit about that?
Actually, that's my preference. I don't know what the working group will agree or not, but yeah, that's something we can think about.
Okay, thank you.
Drew, can you keep it short?
My query is basically, I understand that you in your document you also mentioned type 2 VN model where you want your service model to have a more control. But the approach that we took in the VN model was adding a reference to the topology model, not augmenting the topology model. So I was thinking that instead of creating an IETF network slice model, in fact, you're using the same name as the current NPI model, so it's kind of very confusing. But the main point is that having a completely independent model, is that the right approach? Or if you have these requirements, can it be that IETF network slice NBI model is augmented with a reference to the T topology model, and the rest of the things that you are doing to connectivity matrix anyway makes sense? You also say that you want to generalize that. So if you want to generalize that, isn't that a better modeling approach than what you have currently in the document?
When you say generalize, so you have several questions. The first one, I think about the VN model and the topology model. This is the same way as the ACTN, I think. ACTN for type 2 uses T topology model directly. For the type 1, you have VN model.
As a reference, Shufang, as a reference, not as an augmentation of topology model. In your case, you are using augmentation instead of reference.
If I remember that Yang's modeling description for the VN model is for type 1.
No,
for the
that model
type 2.
supports both. Shufang, no, you are saying what you're saying is incorrect. I'm the author of that document, so I know this well. We support both the types using the same VN model, and both of them reference an abstract node in the T topology so that we can use the connectivity matrix like you are currently using right now.
Well, that's, if you think that's a proper approach, then the current NPI model, if we wish, we can make them to the reference point, but I don't see that easily doable from current status of the model development.
Actually, Shufang, I was thinking, because we have the T service mapping, and in the T service mapping draft, we decided that we don't want to add IETF network slice. It's going to be confusing. In fact, I was proposing, I have a document on this, where we say that IETF network slice getting mapped to T construct in the same way how we did for L3SM and L2SM, etc. So if we follow the same approach, I think that would be a much cleaner solution, where we have IETF network slice as an independent model and use the T service mapping approach to add a reference to the topology. And I know
I'm really sorry to jump into what is a really good conversation, but in the interest of time, can you send that comment to the list and then continue the discussion?
Yeah, I'm not sure I agree with that, because I see you add an extra layer which is not necessary there. So, okay, anyway, yeah, we can talk.
Yeah, but really appreciate the comments. Daniele, last...
I had exactly the same comment that Dhruv just made. So if you wanted to give my 30 seconds to Dhruv, I'm willing to leave them to him.
No, I think the point about having the ability to specify a customized topology in the service request, I think that needs to be discussed. Let's take that to the list. Thanks.
Right. Okay, agree.
Yeah, Luis, I've set you up, but if you prefer to just drive from there, you can drive from there. It's up to you.
I will try to drive from here. Thank you.
Okay.
Okay. So this is Luis Contreras from Telefonica. I will present an update on the draft, trying to describe use cases and attributes for the node-bound interface of the controller. So the motivation for the draft was initially to set up some background in such a way that we could fit other documents in on the topic. So essentially the high-level architecture, the data models, and so, with the idea of creating a clear view of the different use cases that can be mapped to IETF network slice services. So the rationale behind that is that I mean, from the operator perspective, once we have the capabilities of instantiating these network slices, the idea would be to use not only for just one restricted set of use cases, but for whatever use cases that we could have, even services that we can provide today without the notion of a slice. So at the end, to take advantage of the slice concept for instantiating a wide kind of services. So the purpose of the draft is to cover that gap analysis in terms of use cases, identifying SLOs or SLEs, attributes and methods that could be needed for for requesting the slices towards the IETF network slice controller. So the draft has been already presented in previous IETF, so this is just an update on the progress. So the use cases documented so far, we have by now, we documented 5G services. We consider both public and private networks. Also, NFDA-based services, so chaining of network functions that could be deployed in different data centers. Also, network sharing, SD-WAN, and the radio functional splits that are being specified in bodies like ORAN. So the updates in this version, so essentially we were through some fixes in editorial terms, mainly the figures and so. We also added the content related to the private 5G networks. This is a special case that could bring up some new, the need, let's say, defining new requirements. For instance, the fact of probably having multi-homing or the customization of the upstream and downstream rates. And also the fact that this use case can imply that the service provider uses network slices provided even by other companies. That could be the verticals in this case. So we added also a section summarizing the attributes and procedures, so a kind of summary or at the very end part of the document. So the objective that would be to identify comprehensive SLOs, the SLEs, and the procedures that could allow to support whatever use case. So having a solution that could be useful for whatever purpose, say, the wider as possible, right? So that section is yet a work in progress, so need much more work for sure. But well, the idea would be at the end, the main outcome of the document would be to have this kind of summary that could fit the other documents in the working group. So as next steps, the idea is to complete the work in progress. We are considering to add an additional use case about data center interconnection and to elaborate a bit more the summary section. So essentially to complete. We will also scan for additional relevant use cases, if any. So we invite people here if there is something that could be of interest to be documented to share with us and to send to the mailing list and so. So invite contributions for sure. The idea would be for today to collect feedback and comments from the working group, and we are expecting to prepare a new version for the next meeting, including the data center case. So we, the authors, consider that the draft is ready to be adopted. So we would like to ask for working group adoption. We think that this is a valuable document for having a clear view on the needs that could be required to be supported by the IETF network slice controller. And also we think that the recent discussion in the mailing list make this evident, the need of having some document collecting the use cases and the needs that could be expected to feed, let's say, the IETF network slice controller for instantiating the slice services. So with this, I think that it's all from my side. Thank you.
Any comments, questions? This seems like a generally useful document. Well, Dhruv, please go ahead.
This seems useful, but I was also wondering, do you have any suggestions for the framework and Yang model based on all the analysis that you're doing for the use case? Is there any concrete feedback that you have that we as working group can use?
Yes, well, we think yes. For the framework, probably to define potential methods or procedures that could be required for instance, in terms of capabilities that could be required to be supported once we instantiate the slices. For instance, retrieving information from the slices, or there is a case that is not coming now to my mind. Give me just 1 second to think about that. It's related to modification of slices. I cannot remember right now. I will put in the chat later on. And regarding the MBI, yes, for sure, probably to identify SLOs or SLEs that could be required to be there. in order to satisfy some of the use cases that we are documenting.
Thanks.
Charles?
Yeah, hi, Charles Eckel, and at Cisco. Sorry to say that I wasn't aware of this draft until just now, but listening to your presentation and the description of what it covers, I'm interested. So all I can say is I'll take a look and then provide feedback on the list.
Great, thank you.
I see next. Hello.
Yeah, go ahead, please.
Thank you. Thank you, Louis, on the presentation. The NFV at least drew my attention. And are you suggesting that functions can be, specified in the service request? Certain functions to be imposed on the slide? Is that the NFV use case that you talk about? Is that something that?
Well, we are approaching the NFV use case now from the perspective of connectivity. There is some work in NFV detailing that. In fact, we talked earlier about the liaisons for NFV, so I related to ACTN. So all that work is related to with respect to the connectivity and what could be the mechanisms expected for NFV for control the connectivity in terms of requesting capacity and so on and so forth. What you are commenting about the possibility of also including functions, if I don't interpret wrong the question, this is something that is somehow stated in the framework, but in the use case that I comment is not reflected in the document. So could be an option to also, let's say, complement the use case, introducing that point on the picture.
Okay, looks like we've reached the end of the queue. I think there's clearly interest in this. It'd be good to get more discussion on the list. Also particularly interested in hearing if there are objections to adopting this work on the list. You don't have to do it right now. Thank you very much. I think Jay is up next. Switch over. For some reason your slides were in a different order. Okay,
Hello,
you should have controls on the bottom. Thank you.
Okay, thank you. Hello, everyone. This is Jedong from Huawei. I'm going to give an update about this draft, the scalability considerations for the network resource partition. Here are the co-authors of this draft. I'm presenting on behalf of all these co-authors. Okay, first of all, a brief recap about the background, the VPN Plus, and the network slicing. The VPN Plus framework is described in this draft IETF enhanced VPN, and one of the typical use cases is to deliver the IETF network slice services. And in the IETF network slice draft, the high-level realization architecture of IETF network slice is described. It mentions the mapping of the network slice connectivity constructs to the underlying NRPs, as shown in the figure on the right side. So based on that, the IETF network slice draft, an NRP consists of a set of dedicated or shared network resources, and it is associated with a filter topology, so that it can be used to support one or a group of network slice services to help with the scalability issues. The scalability of NRP itself is still important for the widely deployment of IETF network slices for more applications and for more scenarios. So this document provides the scalability considerations of NRP in both the control plane and the data plane. So here are the updates after the last IETF meeting. Basically, the major changes, the name of the draft is changed from the VTN scalability to the NRP scalability. This is based on the terminology discussion in the working group and also the discussion between the draft authors. We think the concept of NRP and the VTN are really similar, but with different context. So it is better to align the terminology in this document with the framework draft about network slicing. And the relationship between the NRP and the VTN is described in the VPN Plus framework draft. So we would suggest to give it a review, and any feedback would be appreciated. In this version, we also add new co-authors as part of the joint effort in alignment between the several network slicing related documents. The next change is some updates about the descriptions and terminologies to better align with the IETF network slice draft. The last one, but not the least one, we try to resolve all the valuable review comments from Adrian and others on the mail list. So thanks a lot for the valuable comments. So here are the next steps. I think this document provides a scalability analysis and optimization suggestions for the data plane and the control plane of the NRP. And it also provides the guidelines to the data plane and control plane mechanisms and the related protocol extensions. So I think this document is useful to guide the other works in the working group and other related protocol working groups. So the authors believe this version is ready for the adoption, and we have sent the adoption request to the mail list at February the 7th this year. Okay, thank you. Comments?
Hi.
Yeah, go ahead.
Okay. Thanks, G, for the great presentation. There was the second slide. There was a diagram that you showed. If you don't mind flipping back, yeah, that's it. So it drew my attention, this diagram, and thank you for compiling it. It's great. In here, you're not mentioning anything about VTN. I know that you had described the relationship between VTN and NRP. Do you still see the need to mention VTN in this document, given the diagram that you have compiled? Thank you.
In this diagram, I think we use NRP instead of VTN. And as I mentioned, that the relationship between the VTN and the NRP is described in the VPN Plus framework. So in this document, I think we changed both the draft name and the terminology in the document from VTN to NRP. I think that should be okay. That's reflected the consensus from the working group and the authors.
Yep, thanks.
Any other comments? Pavan?
No, I just.
Oh, okay. All right. So this is I think this is an interesting document. Also, it would be good to get more discussion. This is a lot like the comments on the last document. It'd be good to get more discussions and see if there's comments or objections to adoption. I think we need a little more review before we do an actual poll. Also, on the discussion of NRP versus VPN plus, I personally think that NRP is a more abstract term, and there's different ways to realize an NRP. So I like that change personally. So I'm glad to see it. So thank you for the work, and look forward to more discussion on the list.
Yeah. Thank you, Lou. Actually, just one quick comment. Actually, this is I think this is not a new draft. We have presented several times. This is just a new version based on the new terminology and the draft name. So the content has already been stable, and perhaps we can consider to start a poll on it, unless there are some significant comments or concerns.
I'm not sure there's a question there. I mean, I think we just said, I mean, I'll talk to Bhavan, see if he sees it differently, but the way we saw it at the start of the meeting is we'd like to see a little more discussion on the list before polling, or at least give opportunity for some discussion.
Okay.
Tarek?
Hello, hello again. I presume you can hear me.
We can.
So yeah, thank you. It's Tarek again, and I'm going to talk to you about a Yang data model for provisioning and managing network resource partition policies. This draft is renamed. It's a 0.0 revision now, but it actually replaces a draft that we had presented earlier multiple times. I am presenting this on behalf of all my co-authors. So let me introduce you a bit of overview on what this data model is trying to cover. There is the network resource partition, which is introduced in the network slicing framework. It's a collection of resources identified in the underlay network to support the network slice service or any other service that needs this logical network structure with the required characteristics. And then we have the NRP policy that's introduced in the solution draft that I provided an update earlier today. The NRP policy is a policy construct that enables the instantiation of mechanisms in support of these service specific control data plane and control plane behaviors on the set of topological elements associated with the NRP. So the NRP policy is the vehicle to instantiate these mechanisms. The draft defines the data model for the management of these NRP policies that can be provisioned and managed on NRP-capable nodes, as well as the controller in packet networks. The latest draft was renamed, as I mentioned earlier, to align, and it does align. It tries to align itself to the network slice framework, as well as the solution base draft mentioned here. So what's in the NRP policy? The NRP policy tries to model a number of modes for partitioning, for creating network resource partitions. One mode is partitioning the network in the control plane only, and the data plane is agnostic of the partitioning. Then we have a mode where we partition the resources in the data plane. And then the last mode is when we partition resources in both the control plane as well as the data plane. In the case of partitioning in the data plane, the packet will need to be identified, so it will carry some field so that we can invoke the data plane per hop behavior on it associated with the network resource partition. So these fields, generically we call them a flow aggregate selector field, and it is provisioned using the NRP policy as well. In the other two modes, we for reservation purposes, we could rely on a distributed or centralized resource reservation manager so that we can do bandwidth aware or traffic engineering. So the data model I'm going to cover today will try to model all these three modes I mentioned earlier. So this is the tree view of the data model. There's a list of NRP policies, and each one of those policies has a name and an ID that are unique. And then there are four major branches: a resource reservation branch, and then a flow aggregate selector branch, per hop behavior, and the topology. I will talk more details on the next slide on each one of those. But the policies list is hanging down of the networks. So we're augmenting this network's path, XPath. because the model can be provisioned on the device or on a controller. So we thought it has to be device agnostic. So I mentioned there are the list has an entry which has a name and an ID, and then there are these key elements. Resource reservation will manage the reservations on this link in the control plane, and then we have a flow aggregate selector that can be carried inside the packet, and then it allows nodes along the path to identify those packets and then associate them with the NRP. The per hop behavior, which is the data plane policies, QS policies that are associated with NRP. And then finally, there are filters that can be invoked so that we can compose the topology that's associated with the network resource partition. I think I'm going to repeat myself here and talk about the reservations, and the resource reservation facilitate preference-based preemption as well as state-aware traffic engineering when we're placing paths in the NRP itself. The flow aggregate selector, I did to touch on this lightly earlier. It's a field carried in the packet. It can take multiple forms. The model is flexible enough to allow multiple variants. So the flow aggregate selector for an NRP can be a range of labels, for example. It can be one label carried in any packet, or it can be an IP destination address, or it can be carried in an extension header in IPv6. So for each of these flavors, there are some drafts that are out there which describe the details of the flow aggregate selector or the field itself. The per hop behavior dictates the QoS data plane that can be associated with the NRP itself. And right now, it's just a string which is resolved on the device. We're not carrying the whole QoS profile along with the policy itself. We're just referencing a profile that sits on the device. And finally, the topology filters. It's a container that it can list multiple filters, and combined will define the set of links and nodes that participate in the NRP topology. The filters itself can be used so that we can override certain reservations or flow aggregate selector on certain topological elements if they're not uniform across the network. So using the filters, we can also override the defaults for the whole NRP policy. And lastly, in terms of next steps, the topology container will be augmented to include a reference to the resultant topology. I did mention the filters are modeled already in the data model, so we can define filters. But after applying the filter on the full network topology, there might be a subset topology that we can reference. And this is what we're going to tackle in the next revision, either through a reference to a topology or other ways. But the idea is that we can show the set of links that match the filter as a result of applying it. We do welcome feedback from the working group on this work. We have presented it multiple times. After doing this next revision, we think we will let the chairs know that it should be ready for working group adoption. But at this time, this is our plan. I think that was it. Thank you. I'm happy to answer any questions that the working group might have.
I don't see anybody else at the mic. Can we go to the next presentation?
Thank you.
Thanks.
Hello, can you hear me?
Yeah,
Yes.
it says you want to share, but I've already given you permission. And I'm a little worried to touch the screen because this is how we ended up with Adrian not being able to talk. So if you don't mind, we'll just go through, just tell me next and I'll advance for you.
Okay, that's good.
I think Adrian was, this was Adrian's theory of how we, ended up with him with no audio. So please continue.
Okay, thank you. This is Wo, and I'm going to present this NLP Young model on behalf of all the authors. Next, please. I think everyone has just heard that Tarek has presented NLP policy model, so it's obvious to wondering what's the difference with this NLP model and the NLP policy model. So my understanding is there are major two differences. One difference is this NLP model is not just about NLP instantiation. Yes, that means NLP creation. This model also includes NLP monitoring and also modification management. And the other major difference from my perspective, the other is topology modeling approach. I will talk about this on the next slides. And here you can see that the NLP model is sit under the network slice controller southbound interface. This is a network configuration model, and it is assumed to be used together with layer, for example, layer 3 VPN network model or layer 2 VPN model to realize the network's slice services. So in this way, different connectivity construct of one or more multiple network slice service can be mapped to NLP resources. So next, please. This is the major difference with the NLP policy model I just mentioned in my understanding. The left hand shows the house network slice connectivity construct, how different, how the connectivity construct map to the NLP resources. As you can see that there are two NLP instance. One is blue, the other is red. So each NLP can accommodate different connectivity construct, like blue network slice service can map to that NLP1, and red can map to NLP2. The red is just a point-to-point connectivity construct, that connection. So we think that each NLP can have its own customized topology to support different connections. So that's the difference is the NLP policy, because NLP policy seems only use the filter policy to the network controller instead of these customized nodes and links to the controller. And framework draft says there are multiple different ways of implementation of NLP topology. So in this model, we are trying to modeling it, try to model all these different approaches. Like the first one is that it could be derived from physical topology. And the other topology could be filter topology, like layer 3 topology, T topology, and even SR topology. And each NLP topology could be just part of these filter topology or the physical topology. It doesn't need to be the whole topology. And we also modeling that multiple NLPs can share some same base layer 3 topology and T topologies. So it's not need that each NLP has its very own topology. So we try to modeling all these approaches. So next, please. Here is we modeling the NLP resources. This is quite different with NLP policy. Also, that we think not only the bandwidth reservation is part of NLP resource. We are modeling also like NLP has its own data plane identifier used to in data packets to map to NLP resources. And also each NLP has its own control plane. In that way, for each NLP root computation, they can constrain with the NLP topology and also the SLO and LSE constraints. So next, please.
You have some people.
Yeah, I'm sure.
Okay.
Yes, please. I can have the comments.
Greg, go ahead.
Clarify what you see as a link of a slice, and what give example of link specific resource.
So your question is, what is the slice service link? Or you mean what is link specific resources, right?
Yeah, because for example, so you say that bandwidth reservation as a network wide and link specific. So the
Yes,
network
I
wide,
mean,
I can imagine that it's a sender.
Oh, it's
or
I mean that for network wide resources, that means that almost every link, they have same bandwidth resources, like 1 gigabits. But if it's for link specific, it means that we can just have like link specific, like 500 megabits can be override for that link. That can I answer my? Does I answer
but
the question?
that seems to be a property of realization of a slice, not the slice itself.
It's not the slice. It's NLP resources. It's not specific to some slice service.
No, but it's how you realize the slice service.
Slice service means that to SDP to another SDP. You mean that, right? That could be a tunnel that
Okay, so
can try
you
through these
view
links.
okay, so you view link as a connection between 2 SDPs.
No, this NLP is like this could be physical topology. This doesn't mean it's abstract node.
but my understanding of what we're trying to achieve is an abstraction. So I would agree that if link is viewed as a connection between two SDPs, but if it's
maybe
a physical,
okay, can I go to the previous slide, please?
yes.
Yes, this one. I mean, this NRP is quite like each link is relevant with the underlay network. It's not the like abstract link between SDP. I mean, like that red point-to-point network slice service, it can map to NRP2, right? So it will traverse two nodes, or it could be with protection, it could be traverse 5 nodes. So is that clear?
Well, yes, it's clear, but that suggests that, well, at least in my understanding, that it should have been a model of the technology that realizes the slice, and then
Yes, this
resources.
is a, yeah, please.
And then resources will be on that. So whether it's a EVPN or if it's VPLS, L2 VPN.
I mean, this NRP could be used for like different VPN. I mean, it doesn't need to be specific to one VPN.
Okay, thank you.
Thank you. Tariq? Tariq? Tariq, you're mute. I cannot hear you.
Tariq, we can hear you.
Maybe you should go on until he, and Tariq, when you
Okay.
get your voice working, just speak up.
Okay. Next, please.
Do you want this one?
I mean, I already, yes, I can directly go to that monitoring one because I just finished resource.
Yeah, that's what I thought. Okay.
Yes, thank you. And yeah, this is what I mentioned about the difference with NRP policy, because this NRP model is also used for monitoring, and also like when a network slice service requested, it can be used to see whether this NRP has the available resources. So like in this NRP instance, each link has its resource bandwidth usage, and it could have the per link delay or loss. So it can be used for the network slice controller to evaluate whether this NRP instance can be used to support a new network slice service. So this is for NRP monitor. We augment the network IETF network model with link specific status. Next, please.
He's back. We can try him again, maybe.
Hello?
Oh, yes.
Yes, we hear
Tariq,
you.
please.
Okay, thank you. Yeah, the last time, the mic didn't give me an option to unmute. So yeah, there was a bug somehow. There was a slide where you were talking about bandwidth reservation. Yeah, exactly. Thank you. Slide number 4. I just want to make a clarification or a correction, because you referenced the NRP policy data model while you were describing the bullets. So in fact, the NRP policy data model covers all 3 bullets that you have, all the 3 bullets, the bandwidth reservation, as well as the data plane selector field, you call it data plane ID, as well as the control plane or the topology associated with the NRP. So that was a clarification. My question now is, my understanding of reading through the document is that you want to use the topology model as a device to configure or provision a device. Is that correct? And if so, it's not usual to use a topology model to provision the device.
Oh, that's my, I don't remember that my, like this model is right now can support device configuration. This is right now is a network. I just on the first page I showed that right now this model is a network model. Maybe
Right,
in the future we can consider whether it can be like used for device, like some attributes can be.
Okay. Maybe I misunderstood, because these attributes that you have on the slide, the 3 of them, will need to be provisioned on the device. Right?
Yes.
The data plane profile, as well as the reservations. And,
yeah, I agree
okay.
with you on this. Yes.
Thank you.
Thank you. So I think this we'll quick go through this. This is almost the last one, and this NLP modification is used to echo the framework draft definition that each NLP is not fixed. It can be extended as network condition change. So the model also support this use case. Next, please. So that's all. And we think this model and also NLP policy model, they don't contradict. And I think this is one approach. NLP policy is the other approach. So that's all from my side. And
Yeah,
we
I think
think,
continuing.
yeah.
Sorry, go on.
Thank you.
Okay. Yeah, we look forward to seeing the discussion, particularly the relationship between the two drafts. And I think,
Yes.
Luis, you're going to try to share locally.
Yep.
So you should be able to do so now.
I'm not sure. It's not being shared, right?
It should let you share. There you go.
Okay.
It says it's being started. I don't see it yet, but that might be a local issue on my side. Ooh, you're sharing your screen. Okay.
Yep.
Okay, great. It looks good. Thank you.
Thank you. So what I will present now is another draft with the idea of exploring the ways of instantiating the IETF network slices in service provider networks by using all the machinery of IETF. So with the tools, let's say, that we have nowadays, right? So I work on this with my colleagues Samir and Oscar from Telefonica, with Victor Lopez from Nokia, and Reza Rukui from Siena. Oh, okay, sorry. So just as a reminder of the goals and and the non-goals of the draft, the idea is to reuse now, okay. So the idea is to reuse existing IETF machinery to operate the IETF network slices. So from our side, to understand how long we could go with the tools that we have today, and evaluate the existing YAM models, the ones that are already released as RFCs, documents adopted in working groups, or even individual drafts, to understand again how far we can go in order to map the idea of network slice with the tools that we have today. And with that exercise, to identify potential gaps in terms of requirements or models or whatever that we could bring back to those models, to those documents. It's not a goal of this draft to define any new YAM model, and not as well to redefine architectures of new requirements. But it's true that we will explore different architectures that could be feasible, let's say, in service provider scenarios. I will comment on that later on. So, okay. So the context, the kind of material that we are using for doing this exercise. In the case of IETF network slices, we are looking at the framework document for sure, also to the use case document that I presented before. This is in terms of requirements, in terms of the framework itself for providing the network slice services, and also to consider the slice attributes and functionalities that could be expected in a slice. From the point of view of network automation, that could be what we could find in the Soulbound interface. We are considering, or the idea is to consider, let's say, service models available, so LXSM, I mean L2SM, L3SM, and so. Also to consider network models, again, layer 2 NM, layer 3 NM, and so. And then considering, if necessary as well, the TE models, the service mapping associated to these TE models, and other models that could come maybe related to ACL, routing policies, and so on and so forth. And from the point of view of architectural framework, we are looking at the RFCs that you can see there. So the framework for automating services and network management, the framework for abstraction and control of the network, so the ACTM framework, and the service models RFC as well. So regarding potential architectural options we are looking at that are now documented in the draft. We are considering 3 of them. The one on the left would be essentially would go in with the idea of having a kind of master controller or hierarchical controller that could host, let's say, as a component maybe, an IETF network slice controller. And being this master controller interacting with different network controllers that could be for multi-technology purposes. So maybe one optical, another one for IP, and so, or even for acting on different parts of the network. The architecture in the middle is essentially the canonical architecture that is being defined in the framework document, so well known in this community. And the one on the right, which consider is to have the network controller as part of a network controller, right? So probably the differences are not so many on this, but our idea would be to try to understand what could be different options to have, right? So updates from the previous version, we introduce an idea of mapping of or relationship between the models that are described based on different architectural options. So essentially with a framework of different service models, how we interpret that could be the mapping. Then we added a new section for service models that previously the content were there, but not the section itself. So we created an independent section for that, for illustrating the network slice mapping case. And then we included an annex trying to do a mapping between the IETF northbound interface service as being defined today with one of the cases that could be to realize that with a layer 3 service model, right? So our idea is to keep progressing on this and identify gaps and so. So I will detail a little bit each of these updates. So regarding the relationship between models, we took the idea of models that is now provided in RFC 8309, where essentially we have on the right side the OSS and BSS YAM models that could be applicable. So we took directly this from the picture, so with no models in that space. And then we took the part of the customer service models and the part of the network service models. In our understanding, how the network slice service model fits would be as part of customer service YAM module, and we could consider two kind of translations. Let's say one could be to the existing service model, the layer 2 SM or the layer 3 SM. So this is why you can see the arrow interconnecting these two. So we could expect some translation from the network slice service model to either layer 2 service model or layer 3 service model. But also we could consider another kind of translation that could be from the IETF network slice service model towards the network service models. Here, probably the arrow, as it is depicted, is a little bit misleading because the intention is not to reflect a kind of east-west interface, but also a kind of, let's say, southbound interface or a southbound translation, let's say. So we will correct this in the next version. So the idea essentially that we reflected in the draft is that we could have this kind of relationship between the models. So taking the parameters, the attributes of the network slice model and being translated either to service model or to network model. So a second update was the addition of this section for network slice mapping to the service model mapping. Again, the context was the text was more or less there, but was not clearly reflected. So we created this new section, and yeah, basically with the idea of aligning with the RFC 8969. And then we created this annex. Probably is also misleading the usage of the word relationship. Here is essentially a mapping between the NSC NBI YAM model and, in this case, the layer 3 service model. This is an initial exercise. It's an ongoing work in progress. So probably it's not exact or not correct at all. But our idea is to keep continuing these kind of exercises to understand what could be potential gaps between the models, or what kind of parameters could not be taken into consideration because let's say the service model or the network model we are mapping to lacks of these capabilities. For instance, in this case, in the layer 3 service model, we see that there could be aspects like packet error rate or so that could be expressed at network slice level that cannot be mapped today at layer 3 service model, right? So this is our objective is somehow to start understanding what could be these kind of gaps that could exist. This does not prevent that later on the slides could be realized in this case with layer 3 service model. Maybe yes, but probably we could consider at the time of realizing the slides with some specific technology to leverage on that technology for accomplishing, for instance, the packet loss rate in this example, right? So this is the analysis that is there. By now is writing as an annex. Our idea would be to take this back to the main body of the document, and probably, for sure, I mean, providing some further examples of mapping. So yeah, at the end, having as a result, as main outcome, what could be those potential gaps between models. So as next step, we will work on version 04. There are a lot of editorial fixes that we need to fix. So apologies for that because the document is not very clean. We will consider, or we are thinking, and this is also some thoughts that we have in mind, to consider new architectural options. I will present after this slide. And yeah, this new version, this clean version, we expect to release as soon as possible. Our objective is also to keep working on detailing the different implementation options. So yeah, the layer 3 service model, layer 2 service model, and so on so far. And for sure, collect additional operational requirements that could result of this gap analysis. With that, trying to provide feedback to the solutions drafts, and for sure, we are open to collect feedback from the working group if this is of interest. Thank you. Oh, sorry, just one the very last slide with this additional proposed architecture. So, but this is totally work in progress. This is not in the document, just to collect feedback from you if possible in this meeting. We are considering two potential architectures, additional ones. The one on your left is essentially to consider the fact that the one service, as requested today, could be later on realized through a network slice. So somehow having a service model on top and a network slice model at the bottom. Okay, this could be maybe, just as an example, could be the case that we receive a layer 3 service model, layer 3 VPN, and we realize that VPN maybe using an OTN slice. That could be an example. The one on the right, essentially what considers is that the network slice controller could be part or could be moved, let's say, to the OSS. So somehow interacting on the top with an existing deployment of SDN control capabilities in the network. So these are just ideas for discussion, and that's all from my side. Thank you.
Two really quick questions, and then we need to move on to the next because you're already stealing time from your next. Go ahead.
Hi, Pavan Biram. The document does make for a good read. It has sufficient amount of detail. Thanks for that. My question is, I mean, how does this relate to the ACT and the working group adopted ACT and document that we have? So my understanding is that it also talks about using the same set of data models, service data models, network data models, and others that we have currently defined. It has the same motivation. It's trying to cater to the same use cases. So how do you see this document related to that document?
Well, I see probably ACTN is an example of how to realize this with a specific architecture. No, probably this could intend to be a little bit more abstract. So maybe we could go with the ICTN or with other kind of solution or framework solution, I guess. But certainly there are some commonalities clear because I mean the architectures are, yeah, I mean ACTN is a kind of realization of an overall architecture, right?
So we can
Sounds
continue
like,
the
it sounds like a good list discussion. We should move on.
Hi,
Dhruv,
yeah, Dhruv here. One quick question in your Yang mapping. There is one more document. I'll put the link in the chat. That document talks about mapping ITF network slices to L2NM as well as T mapping in the same way how we did the T service mapping. So that document already exists, and I think I can just look at it, and maybe you can add it in your list of Yang models there. Thank you.
Thank you, Dhruv.
yeah, so if you could go on to the next and maybe talk 5 minutes. I don't know if you could keep it to 5.
Yes, sorry, I will try to be faster here. So
Thank you.
yeah, this other document intends to go in the direction of understanding how we could map different slices, right? So probably could go in that direction mentioned before about an example of realization and that. So here we explore the way on how to connect 3GPP slices through IETF network slice services. And this is done with Ivan Bikov from Ribbon and my colleague Jose Ordóñez from Telefónica. So the motivation is somehow 3GPP as one of the potential use cases is defining the concept of slicing, having a number of different logical constructs, and trying to create this idea of a slice with particular QoS characteristics. On the other hand, we have all the IETF network slice stuff that I will not comment. So the objective is somehow to understand how both ideas could match at the point of development that they have today in either 3GPP and IETF. So just for understanding 3GPP, in the definition of network slicing is defining a number of constructs, right? So they are defining all this idea of network slice identifiers, and for doing the realization of the slice, they are defining different artifacts. One artifact that somehow determines what could be the interface to be connected. So in this case, we are performing a connection between a central unit user plane 1 with a UPF 1, and we could have different kind of slices with different QoS requirements. One for a has mobile broadband, another one for URL. So the way of distinguishing these kind of slices is through the artifacts that you can see there. The endpoint is determining the kind of interface, so the NGU or the M3 interface, and then they define another artifact which is called EP transport. This EP transport has a number of parameters that we will comment later on, and we could have connection between EP transport for realizing the slice at 3GPP level, but also as in the case at the bottom, we could have even components of 3GPP like the UPF number 3 that does not support slicing. So this is somehow options that 3GPP is considering and is defining. So the idea would be, okay, this is the starting point, this is what 3GPP needs and requires, how we could map this into IETF network slicing. So let's look what EP transport is defining. EP transport is considering a number of parameters. The IP address, which is a mandatory parameter, and is stated as IPv4 or IPv6. Then the logic interface info, which is mandatory as well, and they define a type and interface ID. This would correspond, coming back just 1 second, this would correspond to the VLAN 2 or VLAN 1 that you can see in the IP transport in the figure. So we have the IP address and we have the VLAN. The VLAN will be the interface type and the interface ID, the number of the VLAN. Then we have two optional parameters, the next hop info that will refer to the ingress transport node in case the 3GPP knows about this ingress transport node, and then the QoS profile, which is also optional and could be provisioned on that logical interface in the 3GPP side, let's say. And then the application reference, which is mandatory and essentially refers to the interface. So a preliminary exercise we did for considering these different parameters was to create this kind of table to understand what could be, how we could play with these different parameters in order to map it into an slice. This is also a work in progress, probably is not complete at all, but this is just to consider the different possibilities that we could have in order to realize that slice. Probably this link a little bit with what Bean was commented before about this multiplexing and how to consider the multiplexing with the different identifiers. So then we have this EP transport. So we have that EP transport, and then we have somehow two different concerns. The 3GPP concern, that is what we saw in the figure before with those slices and so. And then on the bottom part, we have the IETF concern. And we need to perform somehow two kind of mappings. The mapping from the EP transport and all the 3GPP concern towards the IETF network slice and the CE part, which we believe the part that is understood by the 3GPP as a customer, and then the mapping between the CE side and the PE side in the network slice part, in the IETF network slice part, okay? So the first one is a mapping that could be natural if we have probably physical solutions, physical devices, because we could leverage on the IP address and so. Probably it's not so clear how to perform that in a case of virtualization, right? And in the case of the IETF part, in the IETF concern, this is all the stuff that has been defined in the framework document and so we could leverage on that work for identifying what could be what can we do at that level. So the idea would be to elaborate more on how we could do, how we could perform these mappings to have a clear idea of how we could realize the slides. Okay. So in the draft, there is a section for discussion.
You're out of time. I'm sorry.
So just for finishing, next steps. Okay. So we intend to prepare a more detailed document for next IETF. So the idea would be to collect feedback from all of you. Thank you.
Let's try to get the two super quick comments from Wen and Shusang.
Yeah, Wim Hendricks, Nokia. One thing that I had is, it seems that would it not be useful for IETF to actually influence the parameters that can be used from, let's say, on the 3GPP interface between IETF side and the radio and the 3GPP side, to influence which parameters we believe are interesting from our side, rather than them just using some of them? Because I see VLAN being used. Personally, I believe flow label for IPv6 would be another nice attribute that we could use, and maybe there is others. So I think it would be good that we try to influence what we would like to have and try to build a liaison with 3GPP potentially on this side.
This is our idea. We are working also in that front.
For our presentation, this is Shusang from Huawei. And we also have a similar document.
We can hear you.
Audio is not working. Shusang, we really couldn't hear you. Jay, if you're coming in for the previous presentation, can you take it to the list? If you're coming in to present instead of Robin, why don't you two tell me who's presenting?
Okay. Hello, can you hear me?
We hear you fine.
Okay, yeah.
And
okay,
you should have controls. You should have controls, and during your presentation, we'd really like to hear about if you took the action from the last meeting where we asked to take a look at the existing framework and propose text there rather than having a standalone document. I don't believe we saw a response on the list, so I'd really like that point to be addressed from the last meeting as you talk. Thank you.
Okay, great. Okay, I also would like to this one. This is Zhenming from Huawei. I will talk about the framework of for the end-to-end IETF network slicing. Okay, next slide. next one.
At the bottom of your screen, next underneath the slides.
Okay, so I will this IETF network slicing framework include two parts. One is the 5G end-to-end network slicing. And the second one is that's for the IETF network slicing. There's the inter-domain network slicing work. Okay, so here this is the journey for the network slicing work. At the beginning, this is the SR-based network slicing realization. Now this is talk about this scalable IETF network slice realization based on the decoupling the topology and the resource for the network slicing. And this draft for the encapsulate the VPN and the VPN ID in the IPv6 data plane has been adopted by the working group. So I think this is also the base for the for us to go on to move to the end-to-end IETF network slice realization. This is this framework draft. Okay, so here we can see that this is the framework for the end-to-end. So there's the 5G end-to-end network slicing. There use the SNSS-AI to identify this the network identify the end-to-end 5G network slice. And also this in the for the transport network, there's multi-domain. So there's we also have this the inter-domain IETF network slicing work. So at the beginning we use the VTN as the terminology, but according to the latest progress of the IETF network slicing architecture document, our draft is aligned with this architecture. We use the NRP as this the terminology. That means the network resource partition. So this is just this the update. Okay. Okay, so here this we also use change this terminology. We use as the local domain NRP ID to indicate this the identifier for the resource for the specific network resource partition. And also we have this the global this NRP ID to represent the global this the network resource partition resource. This is the second one. And then this is the for the 5G end-to-end network slice ID is not a change. We also think that the SNSS-AI can be encapsulated in the forwarding plane and can be mapped to the E2E NRP ID or the local domain NRP ID. Okay. Okay, so this is just this is the requirements about this one. So this in fact this not change much, but this is refine this is the process, especially that's in the at the edge of this the IETF network slicing domain. There's a need to support map the 5G network slice ID to the global NRP ID and the domain NRP ID. And also for the transport network domain, and the domain border nodes should support to map the global NRP ID to the domain NRP ID of the local domain. So this is just to implement the end-to-end mapping between the 5G network slicing to the IETF network slicing, and between the global this NRP ID to the local domain NRP ID. Similar as for the managed plane and the control plane, it should be through the protocol control protocol extension, or this the YAM model to implement the mapping at the edge node for the transport edge devices. All this the all this the edge device of the each domain So this for the implement the mapping. Okay. Okay, so this is just this is the summary of the updates. So that's align the terminology with the IETF network slice and the VPN Plus draft, and also revise this text about the data plane requirements, and also do some of these editorial changes. Okay. Okay, so this is just our this is the step solicit comments and go on to refine this draft. Okay. Okay, that's all.
Okay, thank you. We're running late, so we don't really have time for questions or comments. Please take them to the list. Again, this is a super short document. It's what, 2 or 3 pages of content. It would be great to see if you could figure out if there's an existing document you could combine it with, particularly a working group document. Just send email the list proposing content for an existing document. Thank you.
Okay, thank you, Lou.
So next up, we have Jay. Sorry.
Okay. Hello again. This is a presentation about the considerations about hierarchical IETF network slices. Okay, next page. Here are the backgrounds. I think the hierarchical network slicing is briefly mentioned in the IETF network slice framework draft as below. IETF network slice can be further sliced into other network slices, and recursive composition allows a network slice at one layer to be used by another layer slice. But there's no details about how the hierarchical network slice can be realized. So this document first describes some typical use cases of a hierarchical network slice, and it also provides considerations and the requirements about the technologies that can be used for the hierarchical network slice realization in different network planes. Okay, here we show some typical use cases of the hierarchical IETF network slice. Like the first one is multiple customer level network slices can be created in an industrial network slice. As shown, the first level is can be an education network slice, and the second level there can be multiple network slices for different universities. And in the second case, there can be multiple application network slices in a customer network slice. For example, in the hospital network slice, there can be different network slices for different types of medical services. And the last one is about a wholesale scenario in which a wholesale network slice can be requested to further provide customer network slices for the services. In this case, the wholesale network slice is a level 1 slice, and there can be multiple customer network slices as a level 2 slice in this level 1 slice. Okay, so following some slides, we will show some considerations about the hierarchical network slice realization. The first one is about the resource partitioning in the forwarding plane. Because since we want to support hierarchical slice, the NRP in underlay are used to support one or multiple slice services. And for the hierarchical slicing scenario, the forwarding plane resources need to be able to be partitioned in a hierarchical manner. And we need to show the different levels of NRPs in the network to the up layer planes like the control plane and data plane. There are 2 options about how to modeling the hierarchical NRPs at the link resource level. The first one is we can treat the level 1 slash resource partition on the link as a layer 3 subinterface. And for the second level NRP resource, it can be treated as the separate data channels within the layer 3 subinterface. The second option is we can treat different level 1 network slices as layer 2 sub-interfaces. And for the level 2 network slices, the resource partition can be considered as the data channel within each layer 2 sub-interfaces. So these different options can bring different impacts to the control plane and the managed plane in terms of the network slice management and also the information distribution to the network. The second consideration is about the data plane identification of the hierarchical NRPs, because we need to use the identifier in the data packet to identify both the levels of NRPs. There are also two options of this identifier in the data plane. The first option is we can use a unified NRP ID for both hierarchies. That is, both the first level NRP and the second level NRP use the same format of the identifier, but they're using the different identifier values to distinguish traffic for the first level or the second level. The second option is we may choose to use a hierarchical identifier for both the first level and the second level NRPs, and they can be the two level NRP IDs may be carried in the continuous fields in the packet, or they can be carried in the separate fields, as long as you can use them to match the first level NRP and the second level NRP separately. Here are also some considerations about the control plane and the data plane and management plane. Sorry, there's a typo. The first is the control plane may need to be used for the distribution of the information and the status of the hierarchical NRPs, both among the network nodes and also to the controllers. So with different NRP resource modeling, as mentioned in the previous slides, this information may be advertised as layer 3 or layer 2 information to the network, and this can have different functionality and scalability implications to the control plane. And as the number of the hierarchical network slices increases, we also need to consider the control plane optimizations to support the better scalability. In terms of the management plane functions for the hierarchical network slicing, the management plane need to provide a life cycle management both to the first level network slices and the second level network slices. It should allow to manage the different levels of network slices separately, and it also need to have this information about the relationship between these two level network slices maintained in the management system. Okay, for the next steps, we would like to get some feedbacks and comments about this hierarchical network slice, both about the possible use cases and the requirements, also some further considerations about the realization of hierarchical network slicing. Okay, that's all.
Well, thank you very much. Look forward to the input, and also thank you for going short. You've actually put us back on time, so that's awesome. All right. If you could unmute your mic, you should be able to start talking. We can't hear you. It says you are muted. If you don't have a mute button, hit reload on your browser. That seems to have happened to a few people today. I don't know if there's someone else who could present.
G, can you try presenting? I see you listed as a co-author.
Yeah, this is G again. I think Zhibo has some issue with the mic, so I will present this slides on behalf of him. Also, this is
it's not even showing them as trying to speak. So it's something on the browser interface. If you can hear me, just reload your browser and see if you can then re-enter. And until then, G, if you don't mind, thank you.
You mean to ask Zhibo to try again?
No, I think I just did. Hopefully he hears me, but if you could just start presenting while we're waiting.
Okay.
If it's okay.
So let me try to present on behalf of him. So this is some deployment status and considerations about the IETF network slices in some operators networks. I'm presenting on behalf of these co-authors from the operators. Okay. So this is the introduction. We think network slicing can be used to provide different services and customers with the required connectivity, resource, and performance characteristics. So since the IETF network slice draft described the concept and general framework of IETF network slice, and the realization mechanism and technologies are being discussed and described in the enhanced VPN framework draft. So this document provides some typical deployment cases of the IETF network slice in operators network based on the VPN Plus technologies. It also will provide some considerations about the next steps that operators think will need to be followed for network slice deployment. Okay, next page. This is the first case to use network slicing for multi-industrial networks. Now, in this case, this operator, China Telecom Ningxia, they have a dedicated SRv6-based network for multiple industry services. Currently, this network carries the three major types of service: the healthcare, the education, and the enterprise internet service. And they're planning to introduce more vertical industry services into this network. So for this network, they create separate like VTNs or NRPs with different network resources partitioned. The technology used for the resource partitioning is based on virtual sub-interfaces with dedicated bandwidth. And in the data plane, they're using the SRv6 to identify different resource partitions on the interfaces and the nodes. In the control plane mechanism used here is using SR policy with link affinity as constraints for the SR policy path computation. For this network, operator noticed that with this SR policy-based mechanism to achieve any-to-any connections, it will require a large number of SR policies being provisioned on the network, like full mesh SR policy provisioning. And for this kind of any-to-any connection, they are considering to introduce optimized mechanism to support SRv6 best effort-based network slicing in the next step. Also, as the number of the network slices will increase in the future, to improve the scalability, the plan is to introduce the data plane VTN resource ID to the network slice so that it can reduce the amount of information to be distributed in the control plane, and also to help to reduce the number of the forwarding entries in the data plane. The third consideration is since the industrial network slices within each industrial slice, there will be a per customer network slice introduced in the future. So the hierarchical network slicing solution will be considered as a next step. Next slide, please. Okay, this one is another use case of the network slicing for the fixed mobile convergence network Basically, this is operator using network slicing to provide a separation and the resource isolation between the mobile service, enterprise private line service, and the broadband internet service in the same network. And in this case, they're using SRMPRS as a data plane mechanism, and the resource partitioning is based on flexible Ethernet and the virtual server interface with dedicated bandwidth. For the control plane, it's also use SR policy with the link affinity as a constraint. For this operator, consider that the automatic network slice management operation is an important feature to reduce the operational overhead and complexity introduced by network slicing. So this is a very useful tool, and they want more improvement with this automation capability. And the second thing they consider for the next step is since the number of network slices will increase in this network, they consider to evolve towards a high scalability network slicing solution in the future. Probably they will also need to consider to introduce the slice ID mechanism. Right. Next slide, please. Okay. The next step is we would like to collect some comments, feedbacks from the working group, and we will plan to add more network slice deployment cases and information to the draft in the future. Okay, thank you.
Comments or questions? Yeah, for me, it's very interesting to see this, and I appreciate the it being brought into the IETF. So thank you, all the authors, and apologies to the person who couldn't get his mic working. We've had a lot of that today. Any other comments or questions? We have a minute or two. If someone wants to bring up something from earlier in the session, please go ahead.
Oh, yeah,
yes.
can you hear me? Yes, okay.
Yeah.
The just finished presentation. I want to know what for the cases presented here, are those real cases deployed already, or just still paper-based cases? Thank you.
They're real deployments.
Okay, thank you.
Thank you.
Okay.
Okay, thank you.
Thanks, G. So thanks everyone for two very productive sessions. Hope to see you all in Philly in July. Hope to see you all in person, as many of you as possible. Lou, do you want to close?
No, thank you to all who presented, who are contributing to the working group, and to Luis, who's helping coordinate in room. Thank you all very much, and look forward to seeing you in Philly.
What were you mentioning about the CPs of the So we're working on